point of this lesson is to be able to write linear equations from word problems, but on this you'll be given the slope or the rate of change and some specific point or a specific place in time. So here's our first example problem. You recently went to the dealership and signed a contract saying you would pay $300 a month to lease a car you like. After 8 months, you've paid a total of $5,400 towards your car. So the first thing I want to do here is determine what was given to me. They're talking about paying $300 per month. That sounds a lot like a rate of change to me. So I'm going to highlight that as my rate of change. And I know that because they're giving me 2 units. It's $300 per month. Now the next bit of information is that after 8 months, I've paid $5,400. So they didn't tell me anything about payment up front or my starting payment. They just told me that at 8 months, I've paid $5,400. So this sounds like a point, like an X and Y. The problem is I don't know which is my X value and which is my Y. My independent variable will always be my X. So which of these stands alone? Is it months or money? And I'm going to say it's months. Months is my independent and money is my dependent. And that's because the amount of money I've paid depends on the number of months that have passed. So now I can see they've given me my rate of change, or M, and I have an X value of 8 months and a Y value of $5,400. So I'm going to use that to determine my initial value, or B. Remember that our general equation y equals mx plus b, and I'm going to fill in what I have. We said previously that our M, or our slope, is 300, and I just said that I have an X value of 8 months and a Y value of $5,400. And I'm trying to solve for B, or my initial value. So I'm just going to scroll my screen down so I can solve this. And I'm going to crunch my numbers. I have 300 times 8, which is 2,400, plus B is equal to 5,400. I want to get B alone, so I'm going to subtract 2,400 from both sides. And I find that B is equal to 3,000. Now, since this is a word problem and when we're talking about a real-world situation, it's important to understand what that initial value stands for, what it's representing. So having an initial value of 3,000 means I'm starting with 3,000, and in this case, $3,000, because y-intercept and y value is all money. So to have an initial value of $3,000 means that I had to pay $3,000 up front, and this is very common whenever you buy something, whether it's a car or a house, you have to put a down payment. So here I'm paying $300 a month, but I must have needed to give the dealership $3,000 in order to get the car. That's my down payment for the car. So my starting value, or initial value, in this case is $3,000. So now we go to the next part, which is write our equation. Well, we've done the hardest part. Our equation is y equals mx plus b, as always, and I simply fill in the slope, or rate of change, which in this case was 300, bring down my x, and now my initial value, or b, was 3,000. And there's my final equation. So now the follow-up question allows us to use the equation we just made. It says how much will you have paid towards your car after 12 months? So they're giving me a time. They're telling me after 12 months I have to figure out how much money I have put into the car after 12 months. So I'm going to use the equation that we have, y equals 300x plus 3,000. And now the question is, do I plug in 12 months as my y value, or do I plug in 12 months as my x value? I'm going to scroll back up to the top, And you can see our notation that we made previously is going to help. And up here I made a note to myself saying that months is my x value, or months is my independent variable. So if ever we're talking about months, that's associated with x. So as I come down here and I think to myself, well, where am I going to plug in 12 months? Which variable will I sub that in for? I know that I'm going to have to substitute that for my x value, because x represents months. So once I do that, I fill in everything else, and now I'm going to solve for y. So I have 300 times 12, which is 3600, plus 3000 is equal to y. And as I simplify this, I can see that y is equal to 6600. Now the last step here is to take my answer and interpret it, put it into a concluding sentence, and relate it back to the problem. So how much will I have paid towards my car after 12 months? Well, now I can give a concluding sentence and say I will have paid $6,600 toward the car after 12 months. Again, because y represents money, and we plugged in 12 months into x. Okay, now for our last example. Example 2. Salt Lake City got hit with a snowstorm that left snow accumulating at a rate of 0.75 inches per hour. 4 hours after the snowstorm began, there was 7 inches of snow on the ground. Now we're going to go through the same process. First, let's dissect the problem. I notice that the snow is accumulating, which means the snow is rising at a rate of 0.75 inches per hour. That is going to be our slope, or our rate of change. Next, they say 4 hours after the snowstorm began, there was 7 inches of snow on the ground. So they didn't say anything about the starting amount of snow, but they said 4 hours into the snowstorm. That sounds like an x, y value, or a specific situation to me. At a certain time, there was so much snow on the ground. So now I need to determine, is it 4 hours and 7 inches, or is my x value 7 and my y value 4? Which is my y and which is my x? So to determine that, I'm going to go up here and think I have hours and inches. Which is my independent, which is my dependent variable? So the amount of snow that's on the ground depends on the time that has passed. So that means inches of snow must be my dependent, which is always y. My x value is my independent, which is time, my hours. I mean, that's just happening naturally. The hours doesn't depend on anything. However, the amount of snow depends on how much time has passed. So I'm going to say this is my ordered pair. Now I can use this xy coordinate to determine my initial value by plugging it into the equation, just like the last time. So there's my general formula, y equals mx plus b. And now I'm going to plug in my y value of 7 inches, my rate of 0.75, my x value of 4, and I'm solving for b. So I leave that there. Now I'm just going to scroll down. I have 0.75 times 4, which is 3, plus b equals 7. Subtract 3 from both sides because I want to get b alone. And I find that b is equal to 4. So now I just need to figure out what does that mean in the context of this problem. Well, if 4 is my initial value, I can say that I'm starting with 4, but for what? 4 inches, 4 hours, what are we talking about here? Well, if 4 is my y-intercept, I can look back at my y unit, and the unit that I was associating with y was inches. So I can say my initial value is 4 inches, and in this situation we're talking about snow. So there must have been 4 inches of snow on the ground prior to this snowstorm starting. Now that we've found all our pieces, we can write our equation. Remember, our general formula is y equals mx plus b. I simply plug in my m, which is my rate of change, in this case 0.75, times x plus my y-intercept, which was 4. And there it is. Now for the last step, which is to use the equation we just made. And the question says, how long had it been snowing if there was 11.5 inches of snow on the ground? So I'm going to use our equation, y equals 0.75x plus 4, and I'm going to substitute 11.5 into my equation. But the question is, do I sub it in as my x value, or do I sub it in as my y value? This is where we can look back at our original work, and we can see inches of snow, inches, we said was our y variable. So that is our dependent variable. And time was our x, or our independent. So when we come down here and I know that I have 11.5 inches of snow, 11.5 inches must be plugged into y, because our y variable is representing the amount of snow we have. So here we go. Now I need to do PEMDAS backwards in order to solve for x. So I'm going to subtract 4 from both sides. 0.75x is equal to 7.5. Let me just scroll. And then last step, divide by 0.75 on both sides, because that's the inverse of multiplying by it. And I find that x is equal to 10. Final part now is to just take our answer and put it back into the context of this problem. We needed to determine how long it had been snowing if there was 11.5 inches of snow on the ground. And we just found x, which is hours. X is representing hours. 10 hours. At 10 hours, there was 11.5 inches of snow on the ground. So I just took our answer, put in a concluding sentence saying if there was 11.5 inches of snow on the ground, then it had been snowing for 10 hours, which is what we just found. So here's an overview of all this work that we just did, or I just did, and in class tomorrow we will be practicing this process.